Tonight, I want to take you on a quiet little journey, one that might just change how you see everything. Not in a sudden, explosive way, but in that slow, gentle shift that washes over you when a simple truth finally settles into place. The kind of shift you don't notice at first, until you realize the world feels just a little wider, a little deeper, a little more alive. Because tonight, as you're settling in, we're going to open a door that most people pass by every single day without ever realizing it's there. A door that leads to a truth so familiar you might think you already know it, and yet so mind-bending that once it fully lands, you'll never look at the night sky the same way again. So take a breath. Let the noise of the day soften and drift into the background. Let your shoulders loosen, your mind slow down, and your awareness open just a little wider. Now, imagine yourself walking toward that quiet doorway with me, not rushing, not searching, just allowing, because what waits on the other side isn't complicated. It's simply something you've never been invited to truly feel before. We spend our entire lives beneath the sky. We walk under it. We work under it. We dream under it. And yet, very few of us ever stop to consider what it really means to live inside a galaxy, to exist within a structure so vast that the human mind was never designed to grasp it fully. Most people look up and see stars, but stars are only the surface of the surface of the surface. Behind them, around them, beyond them is an ocean so immense that even the word immense feels too small to hold it. Tonight, we're not here to memorize numbers or repeat facts you've heard before. We're here to step into perspective, the kind of perspective that quietly shifts the ground beneath your feet. Not by fear or shock, but by wonder. Because perspective is powerful. It doesn't shout. It doesn't force. It simply reveals, and once something is revealed, you can't unsee it. Your mind reshapes itself around that new truth, and the world expands in ways that feel almost spiritual. Even if you're not thinking in spiritual terms, that's what this journey is about. It's about discovering that the galaxy you call home, the place where every memory of humanity has unfolded, is far more extraordinary, far more intricate, far more alive with motion and structure than most people ever imagine. It's about realizing that knowledge doesn't disconnect you from life. It deepens your sense of belonging to something unimaginably grand. So tonight, we begin gently. We won't zoom out too fast. We won't throw you into cosmic infinity all at once. Instead, we'll start right where you are, inside a human body, on a small blue world, floating in a quiet pocket of a vast spiral galaxy. For a moment, just hold this image. You, sitting wherever you are right now, are part of a story that began 8 billion years ago. A story written in starlight, gravity, gas, dust, collisions, collapses, expansions. A story so old and so wide that even the word story feels too narrow to describe it. You don't need to understand all of it. You don't need equations or diagrams. All you need tonight is the willingness to let your mind loosen its boundaries and stretch just a bit further than usual. Think of this journey like stepping outside on a cool night when everything feels still. You look up, and suddenly the world seems bigger than your worries, bigger than your routines, bigger than all the noise you carry inside. That's the feeling we're reaching for. Not the overwhelm of infinity, but the calm recognition that you are part of something vast and beautiful. Something that has been unfolding long before you arrived and will continue long after. As we move deeper into this exploration, you may begin to notice a quiet shift inside you. Not fear, not insignificance. Something else. A widening, a softening, a clarity. Because understanding the scale of the Milky Way doesn't make you smaller. It doesn't diminish your importance. If anything, it reveals just how remarkable it is that you're here at all. Conscious, aware, capable of asking questions about the universe that created you. Tonight, we start by opening that first door, the door to perspective, to awe, to presence, to the silent truth that has been hanging above your head since the day you were born. Beyond that door is a galaxy, your galaxy, a structure so vast that even speaking its size out loud fails to capture its reality. A structure spinning, breathing, moving through space with grace and precision, carrying billions of stars and planets along for the ride. But before we explore its spiral arms, its shimmering core, its dark matter halo, and its place in the cosmic web. We need to ground ourselves in the purpose of this journey. And that purpose is simple: to understand where you are, to understand what you're part of, to understand the scale of the home that holds you, not for knowledge alone, but for perspective, for wonder, and for the quiet shift that happens when your mind meets something larger than itself. So tonight, as you sit here listening, let yourself soften into the idea that the Milky Way isn't something out there and a mind. 64. The life praise. It's not a distant object. It's not a concept. It's not a fact in a textbook. It's the place you live. It's the cosmic landscape that shaped the atoms in your body. It's the home that nurtured the star that warms your earth. It's the backdrop against which every moment of human existence has unfolded. And now, slowly, gently, we begin. Welcome to the journey. Welcome to the shift. Welcome to the first step in seeing the universe and yourself with new eyes. As we take our first steps into this vast cosmic landscape, it helps to begin with something familiar, something close enough to feel personal, yet large enough to stretch the imagination. And that something is the Milky Way itself. You may have heard, at one point or another, that our galaxy is big. But big is a small word. It collapses under the weight of what the Milky Way truly is. Tonight, I want to show you that the galaxy you live in is not just another swirl of stars drifting through the dark. It is, quite literally, one of the giants of the universe, a structure so vast and so powerful that even attempting to comprehend it reshapes your sense of place. The Milky Way is special not because we live in it, but because, out of all the galaxies scattered across the universe, it belongs to a rare category, the largest 5%. That's right, 95% of all galaxies ever observed are smaller than the one you call home. It's strange, isn't it? We often think of ourselves as small, the Earth as small, humanity as small, and in many ways, that's true. But the galaxy that holds us, the system of stars, planets, dust, gas, and dark matter we orbit within, it is anything but small. To understand what it means for the Milky Way to be in the top 5%, imagine walking into a city of 1 trillion buildings. Most structures range from tiny shacks to modest homes, but here and there, scattered across the endless blocks, stand a few monumental towers, skyscrapers so tall and so wide that they dominate the skyline. Even from afar, your galaxy is one of those towers. That means when the universe was assembling itself, piecing together stars from clouds of hydrogen, letting gravity sculpt spirals and spheres, something extraordinary happened here. Something allowed the Milky Way to grow far beyond the modest size of an average galaxy. This alone is awe-inspiring. But the deeper truth is even more beautiful. You are living inside a cosmic structure that most galaxies will never grow to become. A rare formation, a giant among millions of dwarfs, a system powerful enough to bend the paths of stars for hundreds of thousands of light years. And yet you experience none of this in your daily life. You go to work, you rest, you dream, all while traveling inside a titan. So let's take a moment, here in the stillness of the night, to truly feel the scale we're talking about. The Milky Way stretches out across 100,000 light years from one end to the other. If you could travel at the speed of light, the fastest speed the universe allows, it would still take you 100,000 years to cross it. Not 1,000, not 10,000, 100,000. And that's just the diameter. That doesn't even include its invisible halo of dark matter, which extends far, far beyond the spiral arms we see in illustrations. Inside this structure, hundreds of billions of stars burn, each one with its own story, its own chemistry, its own gravitational dance. Some stars are enormous, shining with furious energy. Others are faint and quiet. Many have planets. Some might even cradle life, and all of them are carried within the Milky Way's vast gravitational embrace. Now, here's the subtle but profound point. If the Milky Way were average, this alone would already be astonishing. But it isn't average. It is large, unusually large, almost extravagantly large. Most galaxies aren't grand spirals like ours. Most galaxies are dwarf small, irregular shapes holding only a few billion stars. Sometimes fewer. These galaxies drift around larger ones, pulled by their gravity, like fireflies orbiting around lanterns. In this comparison, The Milky Way isn't a lantern, it's a lighthouse. So when astronomers say the Milky Way is in the top 5% by size, they're not exaggerating. They've measured, they've catalogued, they've compared, and over again, the conclusion remains the same. We live in one of the universe's great cities of light, but size isn't just a number. It shapes the story of every star inside the galaxy. It shapes the flow of gas and dust. It shapes how new stars are born, how old stars die, and how entire planetary systems evolve. When a galaxy is large, it means it has lived a complicated life full of mergers, collisions, growth spurts, and transformations that span billions of years. It means it has gravity powerful enough to gather and keep enormous quantities of matter. It means it has a deep history etched into its structure. You are living inside that history. But there's an even more meaningful truth hidden inside this scale. A galaxy this large is statistically far more likely to host complex chemistry, stable star systems, and planets with long, uninterrupted eras of calm, the exact conditions life needs to emerge and thrive. So the Milky Way isn't just large. Its size may be part of the reason you're here at all. That thought alone carries a quiet beauty. It suggests that your existence is not random, not isolated, not drifting in meaningless emptiness, but part of a long cosmic lineage shaped by forces far older and wiser than human time. The more you understand this galaxy, the more you realize that its size is not a fact to memorize, but a relationship to deepen. You're not standing on the outside, looking in. You are a participant in its unfolding, a witness to its vastness, a creation shaped by its structure and history, and perhaps most surprising of all, as enormous as the Milky Way is, as rare, as majestic, as overwhelmingly large as it appears. It is only the beginning, because this giant, this titan, this cosmic lighthouse is just one piece of a much larger story, a story where even giants can seem small. But before we zoom out to that scale, hold on to this. You are living in one of the universe's greatest structures, a galaxy so vast that even thinking about it expands the mind, a galaxy so rare that most others cannot compare, a galaxy so rich and so powerful that it nurtured the conditions for you to exist. This isn't meant to overwhelm you. It's meant to steady you, to remind you that you are part of something vast, ancient, and astonishingly beautiful, something that has been unfolding long before your first breath and will continue long after your last. Tonight, the Milky Way isn't just a scientific concept. It is your home, your inheritance, your place in the cosmic story, and now that you've seen its true scale, we can take the next step, zooming outward again, into the neighborhood that surrounds this great, luminous giant. Now that we've begun to sense how unusual the Milky Way truly is among the countless galaxies scattered across the universe, it's time to step a little closer to see not the comparisons, but the raw scale of the galaxy we call home. And this is the moment when the mind quietly stretches beyond its limits. Because the Milky Way isn't simply big. We could for the different as are. Its size operates on a level that human intuition was never designed to understand. Imagine this for a moment. Light, the fastest thing the universe allows, travels at about 299,000 kilometers every second, so fast that in a single blink, it could loop around the Earth 7 times. And yet, if a beam of light started at one edge of the Milky Way and wanted to reach the other, it wouldn't take a minute, or a day, or even a year. It would take 100,000 years, 100,000 years. Long enough for entire civilizations to rise and collapse, long enough for languages to appear, transform, and disappear, long enough for humanity's entire written history to replay itself dozens of times. That is the width of the place we live in, but even that number barely scratches the surface, because inside this great disk of stars lies an ocean of light stretching farther than any human sense can grasp. Within the Milky Way are between 100 and 400 billion stars, a number so enormous that even if you counted one star every second, without stopping, it would still take thousands of years to finish, and we are inside this ocean. Trying to measure it is like standing in the middle of a vast forest and attempting to count the trees while branches, shadows, and distance hide almost everything from view. We cannot step outside the Milky Way to photograph it. Every spiral image you've ever seen is a reconstruction, an educated portrait built from data, not a snapshot. To truly see the Milky Way from afar, you would have to leave it entirely, and we are nowhere near that ability. So how do we know its size? How do we know how many stars it contains? By studying the faintest clues, the shifts in starlight, the patterns in gas clouds, the gentle tug of gravity, the way certain wavelengths stretch across space, piece by piece, like reconstructing a cathedral from scattered reflections. Astronomers slowly revealed the form of the galaxy we inhabit, and that form is astonishing. A structure so vast that even light takes 100 millennia to cross it, and so dense with stars that the night sky barely hints at the true abundance around us. But here is the beautiful paradox. Even though the Milky Way is too large for us to comprehend, you can see part of it every time you look up on a clear night. That soft, milky band crossing the sky, the one ancient cultures mistook for spilled divine light, is nothing less than billions of distant stars. Their combined glow woven together into a river of white. If you stand somewhere dark enough, far from city lights, that band becomes breathtaking, textured, luminous, almost close enough to touch. And every point of light in that glowing arc is a real star, a real sun, a real system with its own planets, its own worlds, its own possibilities. Some stars are only a few light years away. Others are tens of thousands of light years distant, shining toward you from across the vast sweep of the galaxy, each one like a story unfolding quietly in the dark. This is the architecture inside which Earth exists, not at the center, not in a privileged position, but as a small dot among hundreds of billions of other dots, a fortunate grain of cosmic dust in a spiral arm drifting through space. But this isn't meant to make you feel insignificant. In fact, it's the opposite, because being part of something this vast is a reminder that life is rare, delicate, and extraordinary. Among hundreds of billions of stars, only one of them, our sun, gave rise to oceans, forests, music, memory, and you. And the position of that sun within the Milky Way is not an accident. It's not random. It matters far more than most people realize. Understanding why leads us naturally toward the next chapter of this quiet journey, a chapter where the sheer size of the galaxy becomes more than a number, and begins to explain how life found a foothold on this small, blue world. If the Milky Way is a vast, shining city stretching across 100,000 light-years, then our sun is not in its crowded downtown, nor in its silent, abandoned outskirts. Instead, it lives in a quiet, balanced neighborhood between the spiral arms, a place calm enough for life to flourish, yet rich enough for worlds to form. It is a position so gently precise that life, fragile and easily disrupted, has been able to unfold here for billions of years. The sun lies along a small side branch known as the Orion Spur, tucked between two of the Milky Way's major arms. You can think of it like a peaceful suburban street lying between two massive highways. The major arms are vibrant but violent, full of newborn stars, supernova explosions, fierce radiation, and gravitational chaos. Beautiful, yes, but deadly. Planets forming too close to those regions rarely get the quiet stability life requires. Yet the Orion Spur is calm. The sun's distance from the galactic center, about 26,000 light-years, keeps us safely away from the most dangerous cosmic events. Near the center of the Milky Way lies Sagittarius A*, a supermassive black hole, 4 million times the mass of the sun. Stars there whip around at incredible speeds. Radiation floods the region. Supernovae erupt often. Gravity tears at everything. Life wouldn't simply struggle there, it would be impossible. But if we traveled too far outward, toward the galactic edge, we would meet a different problem: emptiness. The outer regions of the Milky Way lack the heavy elements needed for planets like Earth: carbon, oxygen, iron, silicon, these ingredients of oceans, atmospheres, rocks, and living cells become scarce. Out there, worlds either don't form at all, or form without the richness needed for complex chemistry. Life needs a full cosmic pantry. Our location offers exactly that, even within the Orion Spur. The sun enjoys another precious advantage. It sits between star-forming regions, not inside them. Star nurseries may look beautiful in telescope images, but they are violent environments. Radiation blasts outward from massive newborn stars. Supernova shocks sweep through space. Whole planetary systems are stripped bare before they ever have a chance to evolve. Earth has never faced that threat. Our solar system formed just far enough away to be safe, yet close enough to inherit the chemical richness of past generations of stars. The Sun also moves on a gentle, nearly circular orbit around the galactic center. Many stars travel in stretched, chaotic paths that swing them into dangerous regions, but the Sun glides smoothly around the galaxy every 230 million years. Stability of that kind is rare in the universe. But the Sun has had it for billions of years, and that stability is one of the quiet reasons life had time to become complex, conscious, and curious. Look around our stellar neighborhood, and you'll notice something else unusual: the spacing between stars. Earth's nearest stellar neighbor, Alpha Centauri, is more than 4 light-years away, far enough not to disturb our orbit, but close enough for us to study. If our region were more crowded, gravitational nudges from nearby stars would constantly distort Earth's orbit, destroying climates, shifting seasons, maybe preventing life from surviving at all. But if our neighborhood were emptier, the galaxy would not provide the heavy elements needed for rocky planets. We live in a place that is neither too crowded nor too lonely, a place balanced between calm and richness. Astronomers have a name for this rare region: the galactic habitable zone. It is the thin band around the Milky Way where conditions are stable enough, enriched enough, and peaceful enough for life to survive for billions of years, and the Sun sits squarely within it. Out of all the billions of possible locations inside the Milky Way, life emerged in one of the rare places where the balance is just right. That alone is astonishing. But there is another quiet miracle about our location. Because the Sun sits slightly above the most crowded part of the galactic plane, and because we are not buried in a dense cluster of stars, the night sky is clear enough for us to see outward, far beyond our galaxy. Had Earth lived in a region packed with stars, the sky would be flooded with constant starlight. The universe beyond the Milky Way would be hidden behind a glowing curtain, impossible to observe. But instead, the night sky is dark enough for us to see other galaxies, map the cosmic web, study the expansion of the universe, and trace the origins of everything we know. Our location did not just allow life to exist, it allowed understanding to exist. Earth is not simply lucky to exist, it is lucky to exist here on this small, quiet branch of a spiral arm, in a region calm enough for oceans to settle, atmospheres to stabilize, and life to evolve slowly over billions of years. From this peaceful vantage point, humanity has been able to look outward, to wonder, to question, and to build a picture of the universe far greater than ourselves. And as we continue this journey outward from our home star, the next natural step is to look at the company we keep, the galaxies closest to us, the local group, and the cosmic neighborhood that surrounds the Milky Way. As we continue drifting outward from the quiet region of the Orion Spur, the Milky Way begins to reveal something subtle yet profound. We are not alone. Our galaxy, vast as it is only one member of a small cosmic family. And like any neighborhood, it has its closest companions, some small and gentle, others immense and majestic, each carrying its own history, its own motion, its own quiet influence on the Milky Way. When you look up at the night sky, especially from the southern hemisphere, you may see 2 faint, glowing clouds hanging near the horizon. They look almost like smudges of soft white paint brushed lightly across the dark. These are the Magellanic Clouds, the Large and Small Magellanic Clouds, 2 dwarf galaxies orbiting the Milky Way, like smaller siblings accompanying an older, larger star. They are the closest of our neighbors, drifting alongside us as we all swim through space. Though they appear fragile and delicate from Earth, they are galaxies in their own right, each containing billions of stars. Their soft presence in the sky is a reminder that even on the grand scale of galaxies, smallness does not mean insignificance. These clouds have shaped the Milky Way's evolution for millions of years, pulling gently on our spiral arms, feeding us gas that will one day become new stars, and receiving our gravitational influence in return. Their motion around us is not chaotic but choreographed, as if the Milky Way and its companions have been dancing together since ancient times. And then, farther away, beyond the reach of the naked eye, but not beyond the reach of wonder, lies the greatest of our neighbors, Andromeda. The Andromeda galaxy is a spiral system much like our own, though larger and even more massive. If the Milky Way is a grand cathedral of stars, Andromeda is a vast, towering palace rising above it, majestic, intricate, and radiant. It sits more than 2.5 million light-years away, yet its light still reaches Earth with ease, whispering across the darkness of intergalactic space. Andromeda is the nearest large galaxy to us, the closest giant who shares our cosmic architecture. It mirrors the Milky Way so closely that looking at Andromeda is, in a way, like looking at our own reflection stretched across the void. And though the space between us seems unimaginably wide, the truth is that both galaxies are moving toward each other, slowly, silently, over billions of years. The Milky Way and Andromeda have been drifting along a path that will one day bring them together. This future meeting is not a threat to fear, but an event written into the fabric of the cosmos, an inevitable moment when two great spirals will merge into one. Stars will not collide, the space between them is too vast. Instead, the shapes of the galaxies will blend, stretch, and settle, forming a new, immense system that astronomers call Milky Way. It is a reminder that even galaxies, with all their weight and grandeur, are part of a larger cycle of creation and transformation. The Milky Way is not static, nor is Andromeda. They are travelers on long orbits, guided by gravity, destined to meet. And in this meeting lies the quiet truth that everything in the universe, stars, galaxies, clusters, is always in motion, always evolving, always becoming something new. But Andromeda's importance is not only in its future, even now. It offers perspective. Just as the Milky Way contains hundreds of billions of stars, so does Andromeda. It is a great spiral of worlds, perhaps with civilizations looking back at us with the same curiosity we feel toward them. The distance between us ensures silence, but not separation. The same laws of physics, the same cosmic history, the same ancient star-forming processes shape both galaxies. We are different branches of the same cosmic tree. In the space between the Milky Way and Andromeda, smaller galaxies drift quietly, some orbiting the two giants, others moving freely through the local group. This region is not empty but gently populated, like a peaceful valley between mountains. The Magellanic Clouds, though small, belong to this same family. Andromeda has its own collection of dwarf galaxies as well, each following paths carved by gravity over billions of years. Together, these systems form a structure called the local group, a cluster of roughly 50 galaxies moving through space as a unit, bound by their shared gravitational field. And within this local group, the Milky Way and Andromeda are the two dominant members, the twin anchors around which everything else moves. Their combined mass shapes the motion of every smaller galaxy around them. Their gravitational pull sets the rhythm of this cosmic neighborhood. They are, in a quiet and dignified way, the elders of this region of the universe. Yet despite their size, the Milky Way and Andromeda are not rivals. They are companions, formed from similar cosmic ingredients, guided by similar forces, destined for a shared future. The space between them is vast enough to inspire humility, yet structured enough to remind us that the universe is not chaos, it is order, rhythm, and relationship. Standing on Earth, looking up at the stars, you might never guess that our galaxy has neighbors at all. The night sky feels timeless and still, but in truth, we are riding inside a system that is part of an intricate web of motion. The Magellanic Clouds drift around us like soft lanterns. Andromeda approaches with silent grace. Other small galaxies trail behind, pulled by the same gravity that shapes our stars. In this delicate choreography, the Milky Way does not stand alone. It belongs to a family, a cluster, a shared home stretching millions of light-years across, a reminder that even at the scale of galaxies, nothing exists entirely by itself. And as we continue to expand our view, the local group will soon reveal itself not as the final structure, but as just one neighborhood within a much larger cosmic landscape. The next step of our journey will show how this cluster of galaxies fits into something far grander, structures that stretch across hundreds of millions of light-years, where the Milky Way is only a single thread in a vast cosmic tapestry. When we look at the Milky Way and Andromeda, massive and radiant in their grandeur, it is easy to think of them as isolated titans drifting alone through an endless night. But the truth is softer, more intricate, and far more interconnected. These two great spirals are not solitary wanderers. They are part of a quiet community, an intimate cluster of galaxies bound together by gravity, moving through the cosmos with shared momentum. This small family of galaxies is known as the local group, a neighborhood stretching across 10 million light-years of space. From a distance, the local group might seem almost delicate. 50 galaxies may sound like a lot, but in cosmic terms, it is a small gathering, an oasis of starlight in an ocean of darkness. And yet everything within this cluster moves as part of a single structure, held together by the combined gravity of the Milky Way and Andromeda. These two giants are the anchors of the group, the great weights at the center of the cosmic balance, and around them dozens of smaller galaxies orbit, drift, or trail quietly behind. Most of these galaxies are dwarfs, tiny compared to the Milky Way, containing just a few million or a few 100 million stars. From afar, they look like faint smudges of light, almost ghost-like in their presence, but each one carries its own long history, its own subtle motion, its own role in the delicate web of the local group. They are like small towns surrounding two great cities, contributing to the shared rhythm without drawing attention to themselves. The Large Magellanic Cloud and Small Magellanic Cloud, which we visited earlier, are among these companions. Others, such as the Sculptor Dwarf, the Fornax Dwarf, the Sagittarius Dwarf, and dozens more, orbit either the Milky Way or Andromeda, slowly weaving paths shaped by ancient gravitational agreements. These orbits are not short or simple, they span hundreds of millions of years, moving like threads through time. Each encounter, each slow passage, influences the evolution of the larger galaxies they accompany. Some bring streams of gas that fuel star formation. Others experience tidal stretching, slowly unraveling as they drift too close to their massive neighbors. Andromeda has its own retinue of dwarf galaxies, forming a small constellation of companions that spiral around it like soft embers drifting in a breeze. Together, the Milky Way and Andromeda, along with their satellites, dominate the local group. Their combined mass dictates the motion of the entire cluster. Everything else moves in response to their gravitational pull, as though the two giants are leading a slow, cosmic dance that spans billions of years. But what truly gives the local group its unique character is not the number of galaxies, nor their arrangement, but the fact that this structure is bound together in a universe where most things drift apart. As space expands, distant galaxies are carried away from one another, like boats drifting on an ever-widening sea. But within the local group, the galaxies remain connected, held in place by gravity stronger than the expansion of space itself. This rare balance creates a small pocket of stability in a universe defined by separation. If you could step back far enough, far beyond the reach of any telescope, you would see the 50 galaxies of the local group suspended like glowing grains of dust in a dark, silent chamber. The Milky Way and Andromeda shine brightest, their halos overlapping faintly in the distance. Around them, smaller galaxies gather in soft clusters, forming a gentle triangle of light stretched across millions of light-years, and all of them move together, slowly drifting toward a future shaped by the inevitable collision of the two largest members. But even within this shared motion, the local group is full of quiet complexity. Some galaxies roam loosely on the outskirts, almost unbound, as if deciding whether they truly belong. Others orbit tightly around the Milky Way or Andromeda, locked in gravitational embrace. A few are being torn apart even now, their stars stretched into long streams of light that arc across space like cosmic ribbons. Each of these interactions contributes to the ongoing evolution of the group, reshaping galaxies, redistributing matter, and altering stellar histories. In its entirety, the local group is both fragile and enduring, a structure large enough to hold 50 galaxies, yet small enough to feel intimate on the scale of the universe. It is a family not defined by proximity alone, but by shared destiny. The Milky Way and Andromeda, though separated by vast darkness, are bound so strongly that their paths have been intertwined since the earliest ages of cosmic time. Their future merger is simply the next chapter in a story that began billions of years ago, and Earth, circling its unassuming star in the Orion Spur, is part of that story. Everything we see in the night sky, everything we know about our place in the universe, everything recorded in the motion of galaxies, all of it is shaped by the gravitational web tying the local group together. We exist inside a structure we cannot see directly, but one that influences every star we observe, every nebula we map, every cosmic question we ask. What is most humbling is this: the local group is only a small piece of something far greater. Beyond its boundaries lie clusters of galaxies, vast collections of hundreds or thousands of systems bound together. Beyond those clusters lie superclusters, and beyond them lies the cosmic web itself, a structure so immense that it spans billions of light years and stretches the imagination to its breaking point. But before we zoom outward to that astonishing scale, it's worth pausing here. In this quiet cluster of 50 galaxies, and recognizing that even in the immensity of the universe, we inhabit a place with structure, with relationships, with history. The local group is our cosmic neighborhood, the space in which our galaxy grew, evolved, and found its companions. It is the foundation beneath everything we see in the sky. And now, as the boundaries of the local group begin to fade in our view, we prepare to step into something even larger, the Virgo supercluster, where our small family of galaxies becomes part of a vast continental structure of light stretching across the universe. As we drift outward from the local group, something remarkable begins to happen. The 50 galaxies that once felt like an entire cosmic community begin to shrink in our mental landscape. What seemed vast a moment ago now appears delicate, almost modest, like a small cluster of lights suspended in an ever-widening darkness. This change in perspective isn't meant to diminish the local group, it's meant to prepare us for the next layer of cosmic structure, a layer so immense that even the Milky Way and Andromeda become small features inside it. This larger structure is known as the Virgo supercluster, a sprawling continent of galaxies stretching across more than 100 million light-years of space. If the local group is a neighborhood, then the Virgo supercluster is the entire metropolitan region, a vast web of clusters, groups, filaments, and voids connected by gravity on a scale almost beyond comprehension. From the outside, the Virgo supercluster would not look like a single object. It would resemble a loose, shimmering archipelago of islands scattered across a cosmic ocean. Each island is a cluster of galaxies, some containing hundreds or even thousands of galaxies bound tightly together. Between these clusters lie long, delicate filaments of smaller groups, streams of starlight bridging the darkness, connecting one island to the next. The local group is one of these smaller groups, floating quietly on the outskirts of this enormous structure. Inside the Virgo supercluster, the largest and most dominant concentration of galaxies is the Virgo cluster itself, a massive gravitational hub lying about 55 million light-years away. The Virgo cluster is a place of incredible density, a buzzing galactic city filled with thousands of galaxies drawn inward by a shared gravitational heart. Compared to the quiet pacing of our local group, the Virgo cluster is turbulent, crowded, and dynamic. Galaxies collide more often there. Hot gas flows between them. Gravity shapes everything with a force far stronger than what we experience in our gentle corner of space. And yet, even though the Milky Way is so far from this chaotic center, we are still part of the same overall structure. The local group is connected to the Virgo cluster by gravitational filaments, threads of dark matter and faintly glowing galaxies stretching across millions of light-years. These filaments act as bridges, linking smaller groups to larger clusters, forming the skeleton of the Virgo supercluster. Through these bridges, gravity whispers its quiet instructions, guiding the motion of galaxies, shaping the flow of matter, and arranging the cosmic landscape into patterns both elegant and ancient. Imagine for a moment that you could hover above the Virgo supercluster and look down upon it as a whole. The local group would appear as a tiny fleck of light on one of the outer filaments, almost invisible next to the enormous Virgo cluster. And yet, without that fleck, without the dozens of small groups scattered along the filaments, the structure would not be complete. The The supercluster is not a single object, but a collection of relationships, galaxies held together by gravity, clusters connected by unseen bridges, groups drifting in synchronous motion shaped by the mass of the entire region. This perspective reveals something subtle but profound. The local group is not isolated in the universe. It belongs to a vast, interconnected system, woven together across unimaginable distances. When we map the Virgo supercluster, we are mapping the cosmic environment that shaped our galaxy's history long before the Sun was born. Even now, the motion of the Milky Way is influenced by the gravitational pull of the Virgo cluster and the surrounding supercluster structure. We are moving not randomly, but as part of a much larger flow. The Virgo supercluster is also a reminder of how structure emerges naturally in the universe. Gravity draws galaxies into clusters, clusters into superclusters, superclusters into enormous web-like patterns. This cosmic architecture didn't form suddenly. It grew slowly over billions of years. Guided by the faint fluctuations left over from the Big Bang, what began as tiny ripples in the early universe has now become a magnificent tapestry of matter stretching across billions of light years. And though it is beautiful, the Virgo supercluster is only a transition point in our journey. For as immense as it is not a closed system. It is not even the largest structure we belong to. The Virgo supercluster is part of something even grander, something so enormous that it changes the way we think about space entirely. But before we step outward again, it is worth appreciating just how far we've already zoomed out. From a single star in the Orion Spur, to a galaxy of hundreds of billions of stars, to a cluster of 50 galaxies in the local group, and now to a supercluster containing thousands upon thousands of galaxies spread across millions of light years. Each step outward reveals another layer of context, another level of structure, another reminder that we inhabit a universe full of patterns far greater than ourselves. And yet, for all its immensity, the Virgo supercluster is not chaotic. It has order, it has rhythm, it has boundaries shaped by the pull of gravity. Within these boundaries, galaxies move like schools of fish drifting along hidden currents. The Milky Way is one of those galaxies, one luminous point carried along by a flow that will continue for billions of years, standing on Earth, sheltered by our atmosphere. We rarely feel this motion, but the truth is that our galaxy is part of a vast migration, a journey through the Virgo supercluster guided by the same laws that shape stars and worlds. We are not drifting aimlessly. We are participating in a grand movement, one that stretches from the smallest dwarf galaxy to the largest clusters in our region of space. And now, as the view widens again, the Virgo supercluster itself begins to feel like just one piece of a larger puzzle. Beyond it lies an even greater structure, one that redefines everything we think we know about the size of the universe. This next layer reveals how superclusters connect into a cosmic landscape so vast that even the Virgo supercluster becomes a single thread in a larger cosmic fabric. As we drift outward from the Virgo supercluster, something astonishing begins to unfold. The immense structure that once seemed like the grandest of cosmic landscapes now starts to dissolve into an even larger pattern, as though the universe is quietly revealing deeper layers with every step we take. What was once a sprawling archipelago of galaxies becomes only one province within a far vaster realm, an immense superstructure that stretches across 520 million light-years. This is Laniakea, the immense heaven, a name given to it for a reason that becomes clearer the further we zoom out. Imagine standing at the edge of everything you know and discovering that it is only a small room in a palace you never realized existed. That is the shift in perspective we encounter when we move from the Virgo supercluster to Laniakea. The structures we once thought were enormous clusters, filaments, groups now appear like threads woven into a tapestry so wide that even superclusters become tiny motifs in its design. Laniakea is not a single cluster, but a vast network of them, interconnected by invisible bridges of gravity and dark matter. It includes the Virgo supercluster, the Hydra Centaurus supercluster, and countless other clusters and filaments, all flowing together into a coherent gravitational basin. The local group, with its 50 galaxies, resides on one of the outer edges of this sprawling system, drifting gently within currents of motion that span hundreds of millions of light years. One of the most profound aspects of Laniakea is that it is defined not by what it contains, but by how everything within it moves. Galaxies inside Laniakea are not stationary. They stream along gravitational pathways like rivers converging toward a valley. These flows are gentle, almost imperceptible on human timescales. But over billions of years, they reveal a map of cosmic geography. The Milky Way, Andromeda, and the local group are all drifting toward a region known as the Great Attractor, a mysterious gravitational center that shapes the motions of tens of thousands of galaxies. From within the local group, we don't feel this movement. The stars in our sky appear fixed, serene. But at scales beyond imagination, entire clusters are sliding through space, drawn by the massive structures we cannot see in visible light. Gravity, acting across enormous distances, choreographs a vast dance in which every galaxy participates, often without knowing its role. Laniakea is the stage on which this dance unfolds, a space so large that even the Virgo supercluster is only a ripple in its fabric. To envision Laniakea, imagine a cosmic basin. Everything within this basin flows toward a gravitational low point. This flow, rather than arbitrary boundaries, defines the supercluster's shape. Galaxies that move toward the Great Attractor belong to Laniakea. Those flowing in different directions belong to neighboring superclusters. In this way, the universe arranges itself not by rigid walls, but by the paths matter naturally follows. Laniakea is a map written in motion, and within this vast region there are hundreds of thousands of galaxies, spirals like the Milky Way, ellipticals like massive cosmic orbs, irregular galaxies that look like the remnants of ancient collisions. Each one is its own world, containing billions of stars, billions of planets, billions of possibilities. And yet, all of them, every luminous point, every swirling disk, every quiet dwarf galaxy moves together, each contributing to the gravitational hum of Laniakea. When we step back far enough to see this structure as a whole, something remarkable happens. We begin to notice patterns. The galaxies are not scattered randomly through space. Instead, they form long filaments, vast sheets, and open voids, regions so empty they stretch millions of light-years across. Between these voids, rivers of galaxies flow like glowing veins across the dark, and Laniakea is one such river system, one of the great arteries of the observable universe. Its scale is almost impossible to grasp. To cross Laniakea from one side to the other, even at the speed of light, would take more than 500 million years. 500 million years of uninterrupted travel through regions filled with clusters of galaxies, chains of galaxies, and lonely galaxies suspended between them. This structure is so large that our language struggles to contain it. Even metaphors, oceans, continents, webs feel too small. And yet, for all its immensity, Laniakea gives us a sense of belonging. It tells us that the Milky Way is not drifting aimlessly through the universe, but is part of a vast, interconnected system. The forces that guide our galaxy guide thousands of others. The currents that shape our motion shape the motions of clusters far beyond our reach. We are part of a region of space defined not by isolation but by relationship. In this sense, Laniakea is not simply a structure, it is a home. A cosmic homeland on a scale so grand, it humbles the imagination. It shows us that every galaxy we have ever mapped, every cluster we have ever detected, every filament we have traced, exists within a deeper context. Our place in the universe is not random. It is part of an immense order that extends far beyond what human eyes can see. As we zoom out even further, something almost paradoxical emerges. Even Laniakea, this superstructure spanning 520 million light-years, is not the final layer. Beyond its boundaries, other superclusters connect into an intricate network, the cosmic web, an architecture of unimaginable scale, where matter stretches across billions of light-years in vast, interwoven patterns. The local group belongs to the Virgo supercluster. The Virgo supercluster belongs to Laniakea, and Laniakea is but one thread in the cosmic web. With each step outward, the Milky Way becomes smaller, but our understanding of the universe becomes deeper. We learn that everything is connected, everything is in motion, everything participates in a structure that began forming in the earliest moments after the Big Bang. And now, with Laniakea stretching beneath us like a continent of galaxies, the next natural step is to look at the web itself, the the cosmic structure that binds superclusters into patterns of unimaginable elegance. As we drift outward from Laniakea, the immense supercluster that already stretches 500 million light-years across, something extraordinary becomes visible, something that cannot be understood from within any single galaxy or cluster, but only from the deepest vantage points humanity has ever imagined. Instead of isolated islands of matter scattered through darkness, we begin to see pattern, structure, form. The universe, at its largest scale, reveals a hidden blueprint, an intricate, interconnected framework known as the cosmic web. It is called a web not because it is thin or delicate, but because it is woven. Filaments of galaxies stretch across space like glowing strands, linking clusters together across vast distances. These filaments intersect at nodes, cosmic hubs, where hundreds or thousands of galaxies gather in dense spheres of light. Between these bright intersections lie enormous voids, regions so empty they span hundreds of millions of light-years with barely a single galaxy inside. From afar, the cosmic web looks less like a random scatter of matter and more like the branching of neurons, the structure of coral, or the frost patterns that form on a cold window. Nature repeats its elegance across scales, and here, at the scale of the entire universe, that elegance becomes almost overwhelming. The cosmic web is not merely a poetic idea, it is the actual shape of the universe. Matter is not evenly distributed. It is pulled into these grand filaments by gravity and dark matter, leaving vast, empty regions in between. Galaxies do not drift aimlessly, they migrate along these strands, flowing like currents in a cosmic river. Entire superclusters, including Laniakea itself, are just features along these immense pathways of matter and dark matter. If you could step far enough back, farther than any human instrument has yet allowed, you would see the universe as a glowing mesh suspended in infinite darkness. Each point of light in this mesh is a cluster of galaxies. Each thread is a chain of hundreds of billions of stars. Each intersection marks a gravitational center so massive that it shapes the motion of galaxies tens of millions of light-years away. And every empty region between these threads is a void, silent and dark, expanding slowly as the universe stretches outward. Standing at the scale of the cosmic web, the Milky Way shrinks to a dust mote. Laniakea becomes just one tendril in a structure so vast it defies imagination. And yet, this sense of smallness does not bring insignificance, it brings clarity. We begin to understand that the universe is not chaos. It has architecture, it has rhythm, it has a subtle order shaped by forces older than stars and deeper than light. The cosmic web formed from tiny ripples in the first moments after the Big Bang, regions with slightly more matter pulled in surrounding material. Those regions grew, they stretched, they merged over billions of years. These gravity-driven motions sculpted the universe into its present shape, a sprawling network woven from filaments of galaxies separated by great voids. Even dark matter, invisible and mysterious, followed these same paths, providing the scaffolding on which visible matter could gather. The result is breathtaking, a universe where structure extends across billions of light-years, repeating patterns that feel both alien and familiar. It resembles the branching of trees, the growth of lightning, the networks of rivers. Everywhere in nature, complexity emerges when simple forces act over time, and here, at the cosmic scale, that truth reveals itself with stunning clarity. Within this web, galaxies travel along filaments as if following roads carved by gravity. The Milky Way is moving, not toward some random point in space, but along one of these filaments, drawn forward by the mass of the Virgo supercluster, the Hydra Centaurus region, and the mysterious Great Attractor farther beyond. Our entire galaxy is part of a great flow, a cosmic migration across hundreds of millions of light-years, guided by a gravitational map etched into the fabric of the universe. What is perhaps most astounding is that human beings, tiny as we are, have been able to detect and map this structure. By measuring the motion of thousands of galaxies, by observing cosmic microwave background radiation, and by simulating the evolution of matter over billions of years, we have revealed the hidden architecture beneath everything. We cannot see dark matter directly, yet we see its influence shaping the motion of galaxies. We cannot cross the universe ourselves, yet we can trace the pattern of its threads. The cosmic web teaches us a quiet truth. The universe grows by gathering, connecting, and structuring itself. Galaxies are not accidental. Clusters are not scattered without reason. Superclusters are not isolated islands. Everything is part of a larger flow. Everything belongs to a larger shape. Everything participates in a pattern stretching across time and space. And within this grand arrangement, the voids play an equally important role. These empty regions, as vast as they are silent, help define the shape of the filaments. Without emptiness, there would be no structure. Without the dark expanses, the glowing threads could not emerge. In a quiet way, the voids give form to the universe, just as silence gives shape to music. When we think of the cosmic web, we are not merely observing a scientific phenomenon. We are witnessing the universe revealing its deepest symmetry, its most foundational geometry. It is as if the cosmos has drawn a map of itself, one that shows how galaxies cluster, how matter flows, and how gravity sculpts the grandest structures that exist. And yet, for all its beauty, the cosmic web is not static. It is stretching, expanding. The threads grow thinner. The voids grow larger. The nodes drift farther apart as the universe accelerates in its expansion. What we see today is only a snapshot, one frame in a film spanning tens of billions of years. The cosmic web will continue to evolve long after every star we know has faded. But for now, it offers us a profound gift: perspective. It reminds us that our galaxy, our star, our planet, our lives, all of them are woven into a structure so large that it challenges everything we think we know about scale. And yet, knowing this does not diminish us. Instead, it invites us into a deeper sense of wonder. It shows us that we are part of a universe that is both immense and ordered, both mysterious and knowable. And as we move forward on this journey, the next step reveals something even more surprising, that within this cosmic web, there exist structures so large, so elongated, so unimaginably vast that they push the limits of what our current cosmological theories can explain. These are the Great Walls, the colossal formations that stretch across billions of light years. As we trace the luminous strands of the cosmic web, drifting through its glowing filaments and grand intersections, something else begins to draw our attention, something quieter, darker, and far more mysterious. Between the bright chains of galaxies, between the long, shimmering bridges of matter, lie the voids, immense, haunting regions of space where almost nothing exists at all. These voids are so large that even the word enormous feels too fragile to contain them. Some stretch hundreds of millions of light years across, others span over 1 billion. And yet, inside these vast expanses, one could travel for ages without encountering a single galaxy. No clusters, no filaments, not even the faint glow of distant starlight. It is emptiness on a scale that pushes the human mind to its limit. But the voids are not simply dark gaps between galaxies. They are fundamental features of the universe structures shaped by the same forces that created the cosmic web itself. In a strange and beautiful way, the voids are as important as the filaments, because without these great hollows, the luminous architecture of the universe could not have formed. Just as silence shapes music, emptiness shapes the cosmos. Imagine drifting into one of these voids. At first, nothing feels unusual. Darkness surrounds you. Yes, but space is always dark. Yet, as you move deeper, you realize the darkness is different. It's not just the absence of stars, it is the absence of almost everything. No galaxies, no clusters, no islands of light waiting on the horizon. Even the nearest filament of galaxies might be hundreds of millions of light years away. In such a place, the universe feels not just large, but hollow. It is as though you have entered the spaces between thoughts, the silence between heartbeats, the breath held between one cosmic creation and the next. And yet these voids are not mistakes. They are not flaws in the universe's design. They are the natural outcome of how matter evolved after the Big Bang. In the early universe, matter began to clump together in regions that were slightly denser, pulled inward by gravity. As these clumps grew into filaments and clusters, the areas between them were drained of matter, leaving behind the great hollows we now call voids. The result is a universe where structure and emptiness coexist in a delicate balance. The filaments are the veins, the voids are the spaces between, and both are essential. Without the pull of matter into bright filaments, there would be no galaxies, no stars, no worlds. Without the push of expansion carving out the voids, there would be no room for these structures to grow. What makes the voids truly staggering, however, is not just their size, it is how utterly alone they are. Consider the KBC void, one of the largest known voids in the universe. It is so vast, nearly 2 billion light-years across, that the entire Virgo supercluster, the local group, and all our nearest neighbors would fit inside it many times over. And yet this colossal space contains almost nothing, just a faint scattering of galaxies, like lonely embers drifting through a cold, dark wind. To travel from one side of such a void to the other at the speed of light would take longer than humans have existed, longer than the Earth has had complex life, longer than the time it took the Milky Way to form its spiral arms. That is the kind of silence we are speaking about, a silence so complete, so immense, that it becomes a kind of presence. But here is the quiet beauty in this emptiness. The voids remind us that the universe is not filled with chaos, but with contrast. We notice light because of darkness. We recognize structure because of the empty spaces between. The voids give shape to the filaments, just as shadow gives form to sculpture. In fact, some of the most profound cosmological insights have come from studying these vast hollows. The size, distribution, and evolution of voids reveal how dark energy drives the universe's expansion. They show how dark matter sculpts the cosmic web. They help us understand why galaxies cluster the way they do. In this sense, the voids are not simply empty, they are informative. They are the universe's quiet teachers, and yet, they also carry a philosophical weight that is hard to ignore. For many people, hearing about these unimaginable expanses of emptiness sparks a feeling of smallness, a sense that in a universe so large and hollow, life must be rare, fragile, and maybe even accidental. But there is another way to see it. The very existence of these vast voids means that matter gathered elsewhere, gathered into stars, into galaxies, into planets, into places where chemistry became biology, and biology became thought. Emptiness made room for complexity. Silence made room for life. In a universe without voids, structures like the Milky Way might never have formed. And so, in an unexpected way, we owe our existence not only to the glowing filaments of matter, but to the deep, dark hollows between them. As we reflect on these cosmic voids, we begin to understand something subtle about the universe. It is not full, nor is it empty. It is balanced. The great darkness highlights the great light. The immense hollows allow the clusters to shine, and the vast silence between galaxies makes the presence of even a single star feel profound. Standing on Earth, beneath a night sky filled with points of light, it is easy to forget how rare those lights truly are, how far apart they sit, how much emptiness lies between them. Yet that emptiness does not lessen the beauty of the stars, it amplifies it. Each star becomes a defiant flame against the vast dark. Each galaxy, a blossom of light in a cosmic night that stretches for billions of years in every direction. And as we take one step further outward, beyond even the largest voids, the universe will show us structures so immense that they challenge not only our imagination, but even our current scientific theories. These are the great walls, the enormous sheets of galaxies that span billions of light years, pushing the limits of what we believe possible. As we move beyond the vast voids, those immense hollows that carve the universe into shapes of shadow and light, we begin to encounter structures so large, so extended, so overwhelmingly vast that they almost seem impossible. These are the great walls of the universe, immense sheets and chains of galaxies stretched across billions of light years, forming some of the largest structures ever discovered. If the cosmic web resembles a network of glowing veins, then these walls are its continental plates, massive, sweeping formations that redefine our understanding of scale. At first glance, they seem to defy logic. How can something so large truly exist in a universe governed by rules of expansion, gravity, and cosmic evolution? How can galaxies, separated by light years of empty space, align themselves into patterns that span distances greater than any single supercluster? And yet, They do. The universe, in its quiet grandeur, arranges matter into structures that both humble us and challenge our deepest theories. Perhaps one of the most striking of these formations is the CFA-2 Great Wall, discovered in the late 20th century. This structure extends across more than 500 million light-years, a sweeping curtain of galaxies so vast that it reshaped scientific understanding overnight. Before its discovery, the universe was imagined as mostly scattered clusters with only loose connections. But the CFA-2 Great Wall revealed that matter organizes itself at scales far larger than previously believed. It was like lifting a veil and discovering a mountain range where one expected only scattered stones. But the universe did not stop there. Another formation, known simply as the Sloan Great Wall, is even more staggering, stretching across nearly 4 billion light-years. This colossal structure is so immense that if you could travel along its length at the speed of light, the journey would last longer than the entire existence of the human species. And yet, the Sloan Great Wall is not a single object, but a tapestry of connected clusters and filaments, woven together by gravity's subtle pull over billions of years. As overwhelming as these walls are, they are not static. They formed gradually, emerging from primordial ripples left in the early universe. Over time, those tiny fluctuations grew, pulling matter into threads and sheets. The great voids expanded around them, enhancing their shape. Eventually, these enormous walls became the backbone of the cosmic web, guiding the flow of galaxies and defining the large-scale structure of the universe. But even the Sloan Great Wall, astonishing as it is not the largest structure known. For that, we turn to the Hercules Corona Borealis Great Wall, a formation so massive and so distant that its very existence challenges the limits of our cosmological models. Spanning an estimated 10 billion light-years, this giant stretches across more than 10% of the observable universe. It is a structure so large that some scientists question whether it should even be possible under our current understanding of cosmic evolution. At this scale, the imagination falters. 10 billion light-years is a distance so staggering that it approaches the age of the universe itself. To observe the Hercules Corona Borealis Great Wall is to peer so far into the depths of time that light from its farthest edges began its journey when the cosmos was still young. And yet, there it is, an enormous, shimmering imprint of matter, arranged in ways that stretch human comprehension. What makes these structures especially fascinating is not just their size, but their implications. The existence of such vast formations raises deep questions about how the universe grew from its earliest beginnings. Our cosmological models predict that matter forms structures. Yes, but they also impose limits on how large these structures can be, without breaking the uniformity expected in a universe born from the Big Bang. The Great Walls press against those limits. Some even exceed them. For scientists, this is both thrilling and unsettling. These megastructures hint that the universe may contain complexities and patterns we have not yet grasped. They suggest that gravity and dark matter might interact on scales larger than we once imagined, or that the seeds of structure were laid down in ways that still elude us. In this sense, the Great Walls are not merely objects of awe, they are puzzles waiting to be solved. And yet, for the storyteller, for the dreamer, for anyone who has ever gazed at the night sky and felt a stir of wonder, these walls serve a different purpose. They remind us that the universe is not a monotonous expanse. It is a masterpiece of contrasts, emptiness and abundance, silence and brilliance, chaos and structure. The Great Walls are proof that order can arise from vastness, that beauty can emerge from forces acting over unimaginable distances. From the vantage point of Earth, orbiting an ordinary star in a quiet corner of the Milky Way, these colossal structures are invisible. We cannot see them with the naked eye. We cannot photograph their entirety. They exist only in the data patterns revealed by mapping the positions of millions of galaxies, and yet their presence is undeniable. They form the scaffolding of the universe, the cosmic architecture upon which galaxies, clusters, and superclusters arrange themselves. To contemplate these walls is to confront a paradox. The universe is both too large to fully comprehend and too structured to dismiss as random. It is easy to feel small in the face of such immensity, but smallness does not imply insignificance. If anything, the fact that human beings fragile, temporary, fleeting can detect and understand these structures is a testament to the power of curiosity. Against the backdrop of billions of light years, consciousness becomes an instrument of exploration, extending far beyond the scale of our bodies. As we move forward, the journey will take us even deeper into this tapestry, for beyond the Great Walls lies the full expanse of the observable universe, a sphere stretching more than 93 billion light-years across, containing every galaxy, every cluster, every trace of light that has ever reached us. There, the true number of galaxies reveals itself, not hundreds, not thousands, but trillions. And with that revelation comes an entirely new perspective on our place in the cosmos. As we travel outward from the Great Walls and sweeping filaments already explored, a natural question rises. If those colossal structures are merely parts of an even larger cosmic architecture, then what stands at the very edge of our understanding? What is the largest structure the universe has ever revealed to us? And what does its existence say about the nature of the cosmos itself? The answer brings us to one of the most staggering discoveries in modern astronomy, a structure so vast that it seems almost impossible, so immense that it challenges the very principles on which our models of the universe are built. Its name is the Hercules Corona Borealis Great Wall, and it is, as far as we can currently measure, the largest known structure in the observable universe. Imagine a chain of galaxies, clusters, and superclusters connected in a sweeping arc across the depths of space, a structure not millions, not billions, but tens of billions of light-years across. Early estimates suggest it spans roughly 10 billion light-years from end to end. Even saying the number out loud feels unreal. 10 billion light-years, a length so overwhelming that it reaches across nearly 1/10 of the entire observable universe, a structure so vast that if you could travel at the speed of light, the fastest possible speed allowed by physics, you would still need 10 billion years to cross it. Longer than most galaxies have existed, longer than the sun will live, longer than humanity, Earth, and the entire history of life combined. The sheer scale of it forces the mind to stretch, to move beyond the familiar boundaries of imagination. We are no longer speaking about galaxies, or clusters, or even superclusters. We are speaking of something so large it almost seems to operate at a different level of reality, a cosmic scar, a colossal imprint left on the universe from its earliest moments. And yet, its discovery came not from a photograph or a telescope pointed at a single patch of sky, but from something subtler, gamma-ray bursts. These are the brightest, most energetic explosions known, often created when massive stars collapse or collide. Astronomers mapping the positions of gamma-ray bursts noticed something unexpected, a concentration of them spread across an enormous region of space, too large to be a coincidence, too aligned to be random. Their distribution traced the outline of something colossal, something far greater than any known structure before it. At first, many scientists were skeptical. This couldn't be real, they thought. A structure 10 billion light-years wide shouldn't exist. According to the cosmological principle, one of the foundations of modern cosmology, matter in the universe should be distributed uniformly at very large scales. Structures of this size violate that expectation. They push against the limits of what gravitational forces could have shaped in the time since the Big Bang. Some even exceed those limits entirely. But repeated studies, new data sets, and independent analyses all pointed to the same conclusion. The alignment was real. The pattern was real, and the structure, however improbable, exists. To understand just how extraordinary this is, imagine shrinking the entire observable universe down to the size of Earth. In that scale, the Milky Way would be smaller than a dust grain. The Laniakea supercluster, the enormous cosmic continent that contains us, would be smaller than a sesame seed. And the Hercules Corona Borealis Great Wall, it would stretch across continents. It would be the size of oceans. A single structure dominating the entire map of the cosmos. And yet, despite its unimaginable size, it remains invisible to the naked eye. When you step outside and look at the night sky, you see only a tiny slice of the Milky Way. But somewhere far beyond that faint river of light, beyond the nearby clusters, beyond the Virgo supercluster, beyond Laniakea, and past the great voids, lies this titanic formation, a silent, sprawling monument of the universe's earliest architecture. Of course, We cannot see it directly. Its distance is so vast that much of its light has been traveling toward us for billions of years. What we observe today is a snapshot of a structure as it existed long before our sun was born. You are witnessing the ancient universe, a universe still forming, still settling, still shaping itself into webs, walls, and filaments. The Hercules Corona Borealis Great Wall is a relic from that era, a fossil of cosmic history stretching across the depths of space. Its existence raises profound questions. How did such a vast structure form so early in cosmic time? What forces aligned matter across such an enormous region? And if one structure of this magnitude exists, how many more lie hidden beyond the observable edge? Some scientists speculate that we may be brushing up against the boundaries of our understanding, that these megastructures might hint at deeper physics, or at patterns seeded in the universe before the Big Bang's inflationary expansion smoothed everything out. Others suggest more modest explanations, urging caution, reminding us that the observable universe is limited, and our interpretations are shaped by incomplete data. But whether or not we fully understand how it came to be, the Hercules Corona Borealis Great Wall stands as a testament to something essential. The universe is not small, not simple, not easily contained within the models we build. It is a place of surprises, a place of wonders, a place where structures too vast to imagine quietly stretch across the sky. And here is the part that matters most, the part that touches us, even from such a vast distance. Despite its immensity, despite its unimaginable scale, this great wall does not make us insignificant. If anything, it emphasizes the miracle of awareness, because in all the sweeping grandeur of the cosmos, in all the cold beauty of its structures, it is here, on one small world orbiting one quiet star, that consciousness arose. It is here that the universe looks back at itself with curiosity, humility, and wonder. The Hercules Corona Borealis Great Wall reminds us that we are part of a universe far more intricate than we ever imagined. But it also reminds us that comprehension itself is a kind of greatness, that to witness, to question, to understand is its own form of cosmic significance. And with this realization, we continue our journey outward, ready to see the universe, not just in terms of size, but in terms of meaning. As we move outward from the largest structures ever discovered, the mind naturally begins to ask a simple but overwhelming question. In a universe that builds filaments billions of light years long, how many galaxies must exist within it? How many islands of stars are scattered across the cosmic sea? And how many others, far beyond our faintest horizon, continue drifting in darkness, forever unseen? For most of human history, the answer would have seemed almost absurdly small. In ancient times, we believed the Milky Way was everything, a single glowing band that held all the stars that existed. Even as telescopes improved and the night sky opened wider, we imagined perhaps a few thousand distant suns. Then, in the early 20th century, we realized the Milky Way was a galaxy, and Andromeda was another. And suddenly, the universe multiplied. What we thought were clouds were actually entire galaxies, each containing billions of stars. But nothing, not even that revelation, prepared us for what modern astronomy would uncover. Today, thanks to powerful instruments like the Hubble Space Telescope, the James Webb Space Telescope, and countless ground-based observatories, we estimate that the observable universe contains around 2 trillion galaxies. 2 trillion. A number so large that it breaks free of the imagination and enters a realm of quiet astonishment. It is not a number you picture. It is a number you feel like the weight of an ocean pressing against the limits of the mind. Imagine for a moment shrinking every galaxy in the universe to the size of a single grain of sand. One tiny grain, no larger than what you might find stuck to your fingertip after a walk on the beach. Now imagine you needed enough grains to fill a vast landscape: beaches, dunes, deserts, all shimmering with sand. That would be 2 trillion, and somewhere in that endless desert sits the Milky Way. Not the brightest grain, not the largest, just one among trillions. But this number didn't come easily. It wasn't measured by simply counting galaxies in a photograph. It came from a slow accumulation of insight, a layering of observations, models, and mathematical approximations. When Hubble pointed into what seemed like an empty patch of sky in the 1,990 seconds, Astronomers expected darkness. Instead, they found thousands of galaxies glowing at the edge of visibility. Tiny shapes, spirals, ellipticals, irregular forms, light that had been traveling for billions of years before it reached the telescope's mirror. That first deep field image changed everything. It revealed that even the darkest corners of the sky were overflowing with galaxies. Later, deep fields confirmed it, and then the James Webb Space Telescope expanded it further. In regions where Hubble saw a few thousand galaxies, Webb saw tens of thousands, and in every direction, as far as our instruments can peer, the pattern holds: galaxies upon galaxies, layered like dust motes, suspended in a beam of cosmic light. But what makes the number truly astonishing is that this count 2 trillion refers only to the observable universe. The universe we can see is limited by the speed of light and the expansion of space. We cannot see beyond the cosmic horizon. Everything farther than 46 billion light-years is forever out of reach. If galaxies exist beyond that boundary, and almost certainly they do, we will never see them. Not because our telescopes are too weak, but because the very laws of physics prevent their light from ever reaching us, which means 2 trillion is not the total number. It is only the number we can see from our tiny corner, our limited vantage point inside an expanding cosmic bubble. If the universe extends infinitely, then the true number of galaxies may also be infinite. Not merely billions, not trillions, but unending. A vastness beyond arithmetic. And yet, even within the observable universe, the variation among galaxies is extraordinary. Some are monstrous giants like IC 1101, containing trillions of stars. Others are tiny dwarf galaxies with only a few million stars. Most lie somewhere in between irregular shapes. Spirals, ellipticals, slowly rotating or drifting quietly in isolation. Together, they form a cosmic ecosystem, linked by gravity, bound within clusters and superclusters, arranged along filaments stretching across the universe. When you learn that there are 2 trillion galaxies, it is easy to feel small, to think of yourself as a flicker on a flicker, drifting through a cosmos indifferent to your existence. But the truth is more nuanced, more beautiful, because despite the immensity of the universe, despite the overwhelming number of galaxies scattered across its depth, consciousness, as far as we know, arose here, on one planet, orbiting one star, in one galaxy among trillions, and the fact that you are aware of this vastness does not diminish you, it elevates you. A galaxy is a magnificent thing, hundreds of billions of stars, rotating in silence, alive with movement and light, but a galaxy does not know that it is beautiful. A galaxy cannot reflect upon its own existence. A galaxy cannot look across billions of light years and wonder who else might be doing the same. You can, and that ability, that fragile, shimmering spark of awareness is rarer than any galaxy, rarer than any cluster, rarer than any cosmic wall stretching across the sky. In a universe of 2 trillion galaxies, consciousness may be the rarest element of all. When astronomers map the cosmos, they do not simply count galaxies. They trace the evolution of time itself. They observe galaxies that existed billions of years ago, still in their infancy. They watch the universe unfold like a story told in light, each galaxy a chapter, each deep field a portal into the past. Some galaxies are so distant that the light reaching us today left them before Earth formed. Others are so ancient that by the time their light reaches our telescopes, they may no longer exist at all. What we see in the sky is not just space, it is history. And still, the galaxies keep multiplying in our equations. New instruments sharpen the faintest glimmers. More deep fields reveal more clusters. More simulations show more structure hidden beneath the cosmic web. 2 trillion is not an ending. It is a beginning, a first estimate, a stepping stone into the unknown. It reminds us of a truth we often forget. We are living inside a universe still revealing itself. Every new telescope widens the stage. Every discovery shifts the boundaries. And every count of galaxies, no matter how large, is only a whisper of the full symphony. So when you stand beneath the night sky, looking up at the Milky Way, remember this: you are not seeing one galaxy. You are seeing one out of 2 trillion. A single island in a cosmic ocean so vast that even light cannot cross it in a lifetime. And yet, here you are, a being made of stardust, aware of the stardust around you, gazing into a universe large enough to humble, yet intimate enough to hold you. This is the scale of the cosmos. This is the wonder of 2 trillion galaxies. When you gaze at the Milky Way stretching softly across the night sky, it's easy to forget that galaxies, like living beings, come in many forms, shapes, colors, movements, histories, each one telling a different story written in starlight. And the Milky Way, the place we call home, fits into this cosmic family in ways both familiar and remarkable. To understand its true nature, you have to see it not as an isolated island, but as one member of a vast and diverse population, a population of galaxies that range from the smallest flickers to the greatest giants the universe has ever built. Astronomers classify galaxies into broad categories: spirals, ellipticals, and irregulars, each shaped by time, gravity, collisions, and the quiet flow of cosmic evolution. The Milky Way sits comfortably within the spiral family, a graceful barred spiral with arms winding outward like celestial rivers. If you could step outside the galaxy and look back, you would see a bright core crossed by a central bar of stars, with luminous arms curling outward in gentle arcs. It is a structure both orderly and alive, rotating like a slow cosmic dance. This makes the Milky Way part of a group that includes some of the most beautiful galaxies ever observed, spirals like Andromeda, the Triangulum Galaxy, and the magnificent Whirlpool Galaxy. Spirals are rich with gas and dust, filled with young blue stars burning brightly in their spiral arms. These galaxies are still actively forming stars, still growing, still reshaping themselves as time passes. But here is where the story becomes more interesting. Not all galaxies share this elegance. Many are ellipticals, huge, rounded structures filled with older stars, glowing with a reddish hue. These galaxies have little gas left, little star formation remaining, and often sit at the centers of clusters like ancient monarchs surrounded by smaller subjects. Their shapes are smooth, almost featureless, like cosmic fossils marking the end of a long evolutionary path. And some of them are enormous, far larger than the Milky Way, containing trillions of stars compressed into dense, luminous cores. Then there are the irregular galaxies scattered, distorted shapes with no clear structure at all. These galaxies are chaotic, the result of collisions or gravitational disturbances, like cosmic storms frozen in time. They may be small and fragile compared to spirals and ellipticals, but they are crucial building blocks of the universe, reminders of how galaxies once looked in the universe's earliest ages. Within this grand classification system, the Milky Way occupies a middle ground, a large, well-structured spiral galaxy that is neither the biggest nor the smallest, neither the oldest nor the youngest, neither the most violent nor the most serene. And yet, this middle ground is where life found its opportunity, because the Milky Way strikes a delicate balance between order and activity, enough star formation to sustain renewal, but not so much chaos that drifting planets are constantly sterilized by radiation and supernovae. In many ways, the Milky Way is an ideal environment, large enough to have complexity, structure, and diversity, calm enough to allow stable planetary systems to persist for billions of years, rich enough in heavy elements to form Earth-like worlds, and organized enough that the Sun could orbit safely in the galactic suburbs, far from the dangerous density of the central bulge. When astronomers classify galaxies, they're not just putting them into boxes. They are tracing patterns, relationships, and evolutionary histories. Spiral galaxies tend to form in quieter environments where collisions are less frequent. Elliptical galaxies often arise from mergers, 2 or more spirals colliding and blending into a smoother shape. Irregulars sit somewhere in between, constantly reshaped by their neighbors. So where does the Milky Way stand in the grand evolutionary picture? It is a spiral in its mature phase, stable, structured, and steadily rotating. But it hasn't always looked like this. Billions of years ago, it was smaller, more chaotic, still assembling itself from a swarm of smaller galaxies, long before the Sun was born. The Milky Way cannibalized dwarf galaxies and star clusters, absorbing their stars and growing its majestic spiral arms. Even today, Remnants of those ancient collisions still drift through the halo stellar streams, curling like faint fingerprints of long-lost companions. And its future? One day, the Milky Way will collide with Andromeda, merging into an elliptical galaxy. Its spiral structure will be erased as gravity tears and reshapes it. The Milky Way, as we know it, will vanish. But that is the destiny of spirals, a reminder that classification is not a permanent identity, but a moment in a galaxy's life cycle. Understanding the Milky Way's classification gives it context. Instead of being an isolated marvel, it becomes part of the universe's larger story, one chapter in an evolutionary sequence stretching back 13 billion years. Seen in this light, the Milky Way is an active participant in cosmic history, not just a place where stars exist, but a living structure shaped by time, gravity, and chance. And this perspective brings something else into focus: the rarity of our home. Giant ellipticals may contain trillions of stars, but their internal violence and lack of gas make them poor cradles for life. Dwarf galaxies are abundant, but they lack the stability and resources needed for long-term habitability. Irregulars are turbulent and unpredictable, spirals especially large. Stable spirals may be the sweet spot for life in the cosmos, which means the Milky Way is not merely one spiral among many. It is one of the rare spirals with the right size, the right structure, the right composition, and the right stability to host billions of potentially habitable worlds. It is an environment finely balanced between activity and calm, creation and preservation. A galaxy where star formation continues gently, where chemical richness allows planets to form, and where life can arise and persist over billions of years. When you classify the Milky Way, you are not just labeling it, you are understanding the conditions that made you possible. You are understanding why the sun formed where it did, why Earth could cool and stabilize, why life had the time it needed to evolve, why consciousness had space to emerge in a universe filled with chaos, collisions, and extremes. The Milky Way is a rare refuge, a place where order and turbulence coexist in harmony, a place where stars can live long, where planets can remain stable, and where life can slowly awaken to the beauty of the cosmos. When you see it through this lens, the Milky Way becomes more than a classification, more than a spiral, more than a number in an astronomical catalogue. It becomes a home shaped by cosmic forces across billions of years, a home whose very structure made your existence possible. And in this understanding, the galaxy reveals its deeper truth. It is not just one spiral among billions, it is the spiral that holds your story. When we picture galaxies, our minds tend to jump to the giants, the elegant spirals with arms stretched like cosmic rivers, the massive ellipticals glowing like ancient embers, the luminous whirlpools and majestic disks that dominate astronomy books and telescope images. These are the galaxies that capture our imagination, the ones we paint, name, celebrate, and admire. They are bright, they are beautiful, they command attention, but in the quiet truth of the universe, these giants are the exceptions. The real population of galaxies, the ones that shape the cosmic landscape by sheer number, are not grand or glorious. They are small, faint, almost unnoticed. They are the dwarf galaxies, the humble majority of the cosmos. It's a paradox that feels almost poetic. The universe is filled with structures so enormous they defy comprehension. And yet most of its galaxies are tiny, fragile islands of stars only a fraction the size of the Milky Way. If the giants are cities filled with light, then dwarf galaxies are small villages scattered across a vast countryside, far more numerous, far more modest, and yet fundamentally important to the structure of everything. A typical dwarf galaxy contains anywhere from a few million to a few billion stars, a stark contrast to the Milky Way's hundreds of billions. Many dwarfs have no elegant spiral arms, no bright core, no dramatic silhouette. Some are spheres of old, red stars drifting in silence. Others are diffuse clouds of gas and dust, barely held together by gravity. Some look like smudges of fog on the edge of detection. Seen from afar, they are faint whispers in the cosmic dark. And yet, they matter, more than we once realized. Dwarf galaxies are the scaffolding of the universe, the building blocks from which larger galaxies grow. In the early universe, when everything was smaller, more chaotic, more eager to collapse into structure. Dwarf galaxies were everywhere. They merged, collided, and were absorbed into larger systems. Over billions of years, their stars became part of bigger galaxies like the Milky Way. Many of the stars you see in the sky tonight were born in long-lost dwarf galaxies that no longer exist as separate entities. Even today, the Milky Way is still surrounded by dozens of dwarfs, the large and small Magellanic Clouds being the most famous. Others, like the Sagittarius dwarf and the Fornax dwarf, orbit quietly, their stars pulled slowly into our galaxy by gravity's patient hand. These dwarfs are like companions, drifting around us, feeding the Milky Way with fresh material, shaping its evolution, contributing stars to its halo, and providing clues to its ancient past. In fact, one of the greatest challenges in modern astronomy is simply detecting them. Many dwarf galaxies are so faint that they blend into the darkness invisible unless you know exactly where to look. Some of the smallest, called ultra-faint dwarfs, contain only a few thousand stars. If you place them in the night sky, you would never notice them at all. They are the cosmic equivalent of candle flames seen from across a desert. And yet, those tiny galaxies may offer some of the deepest insights into dark matter. Because dwarfs are lightweight, fragile systems, they cannot survive without the gravitational glue of dark matter holding them together. Their survival tells astronomers where dark matter is, how it behaves, and how it shaped the early universe. In this way, dwarf galaxies are like cosmic fossils, delicate, ancient, and deeply informative. But the story reaches even further. When cosmologists simulate the evolution of the universe, they repeatedly find that dwarf galaxies should be everywhere, thousands of small systems orbiting every major galaxy. And while we have detected many, there are still far fewer than the simulations predict. This is the famous missing satellites problem. It suggests one of two things. Either many dwarfs are so faint we simply haven't detected them yet, or our understanding of dark matter and galaxy formation is incomplete. Either way, dwarf galaxies sit at the heart of some of the biggest scientific questions we have. And here lies a quiet truth. Even though we rarely see them in telescope photos or hear about them in documentaries, dwarf galaxies are responsible for shaping much of the universe. Without them, the Milky Way wouldn't look the way it does. Without them, the cosmic web wouldn't have the structure it has. Without them, the early universe could never have transitioned from a smooth fog of matter into the rich tapestry of galaxies we see today. Spiral galaxies like the Milky Way, Andromeda, and Triangulum may impress us with their beauty, but they are just the final chapters of a much older story. Dwarf galaxies wrote the first chapters. They formed first. They merged first. They lit the earliest stars. They seeded the cosmic landscape with the ingredients of everything that came later. And in a universe of 2 trillion galaxies, the giants number only in the hundreds of billions at most. The dwarfs account for the overwhelming majority, perhaps 90% of all galaxies. They are the quiet chorus behind the grand symphony of the cosmos. Yet this majority is almost invisible. You cannot see most dwarf galaxies from Earth. Even with the most powerful telescopes, many remain just beyond the limit of detection. Their faint light never reaches us. Their stories lie hidden in the dark, whispered through gravitational effects rather than glowing through telescopic images. But invisibility does not equal insignificance. If anything, the dwarfs remind us of a simple fact, one that echoes through both science and life. You don't have to be large to be essential. The universe is built from small things, quiet things, things that go unnoticed by most observers. And sometimes, those are the things that shape everything else. So the next time you look up at the Milky Way and marvel at its grandeur, remember this: your galaxy did not grow large on its own. It was fed, built, and sculpted by countless smaller galaxies that came before it. It carries within it the remnants of ancient dwarfs absorbed billions of years ago. It is, in many ways, a mosaic, a collection of countless small stories woven into a single, sweeping spiral. In the end, dwarf galaxies are not merely the most numerous galaxies in the universe. They are its foundation. They are its memory. They are its quiet architects, and their existence gently reminds us that the universe, in all its immensity, is built not only from the grand and the spectacular, but from the overlooked and the small, the countless little lights that, together, create the cosmos we see today. To understand the Milky Way as it exists today, a majestic barred spiral with hundreds of billions of stars sweeping gracefully around a glowing core, you must journey back to a time before anything resembling a galaxy existed. A time when the universe was dark, dense, and still finding its shape. Because the Milky Way did not appear fully formed, it grew from smaller pieces, gathered itself through countless mergers, collisions, and cosmic accidents. Its history is not a single story, but a tapestry woven from many smaller ones, threads pulled from ancient dwarf galaxies, interstellar gas clouds, and star clusters forged in the fire of the early cosmos. In the beginning, shortly after the Big Bang, the universe was a vast, expanding fog, a mostly uniform field of hydrogen, helium, and dark matter stretching in every direction. There were no galaxies yet, no stars, no structure, just a cooling sea of potential. But even in that smoothness, there were tiny fluctuations, slight differences in density, like gentle ripples on the surface of a pond. Over time, gravity amplified these ripples. Regions, slightly denser than their surroundings, began to collapse inward, pulling in nearby matter. These collapses formed the seeds of the first small galaxies, the primordial building blocks from which larger galaxies would eventually grow. The Milky Way began as one of these early structures, a small gathering of gas and dark matter whose gravity grew stronger as it accumulated mass. But the early universe was turbulent and crowded. Everywhere, small proto-galaxies collided, merged, and tore each other apart. The Milky Way's earliest form likely collided with dozens of others, absorbing their stars and gas, growing larger with each encounter. It was not yet a spiral. It was messy, chaotic, more like a storm cloud of stars than a well-ordered system. As billions of years passed, these collisions continued. Every time two small galaxies met, their stars would be thrown into new orbits, their gas clouds compressed, igniting bursts of star formation. Slowly, out of this chaos, a disk began to take shape, a rotating structure flattened by angular momentum, where new stars could form in relative stability. This emerging disk is the ancestor of the Milky Way's spiral arms, but the Milky Way did not grow only from within. It grew by consuming others. Evidence of this ancient appetite still surrounds us today. Stellar streams long, faint traces of stars stretched across the sky, remnants of dwarf galaxies torn apart by our galaxy's gravity. The Sagittarius dwarf galaxy, currently being shredded and absorbed, is simply the latest in a long line of such events. Billions of years ago, many other dwarfs met the same fate, their stars now part of the Milky Way's halo, their identities erased, but their contributions preserved. One of the most significant events in the galaxy's history was a collision with an early massive dwarf galaxy that astronomers call Gaia Enceladus, or the Sausage Galaxy, a poetic name born from the shape of its star's orbits. This ancient merger, which occurred around 10 billion years ago, reshaped the Milky Way dramatically. It heated the early disk, flung stars into the halo, and triggered new waves of star formation. Some of the oldest stars in the sky today owe their origins to that collision. In a way, Gaia Enceladus is still with us, not as a separate galaxy, but as part of the very structure of the Milky Way. After these tumultuous early years, the galaxy began to settle. The rotating disk grew more defined. Spiral arms emerged as density waves rippling through gas clouds, forming stars along their length. The central bulge brightened with older stars, while the outer disk continued to grow slowly, fed by streams of gas flowing inward from intergalactic space. Over time, the Milky Way developed the elegant structure we recognize today: a bright central bar, sweeping spiral arms, a vast halo of stars, and an invisible envelope of dark matter that binds everything together. Even now, the Milky Way is still evolving. Star formation continues in our spiral arms, especially in giant molecular clouds like the Orion Nebula. Gas from the intergalactic medium continues to fall inward, replenishing the galaxy's supply of star-forming material. And dwarf galaxies continue to orbit and merge with us, feeding the Milky Way just as they did billions of years ago. The past is not finished. The story continues, But the most dramatic chapter is still in the future. In about 4 billion years, the Milky Way will collide with Andromeda, a slow-motion event that will take hundreds of millions of years to complete. The two great spirals will merge into a single massive elliptical galaxy, often called Milky Way. Their stars will be reshaped, their disks disrupted, their gas clouds compressed. New stars will form as the galaxies combine, then slowly fade as the available gas dwindles. The Milky Way as we know it will cease to exist. But its stars, including our Sun, if it still survives, will continue their journeys inside the new, merged galaxy. When you place all of this in perspective, something important becomes clear. The Milky Way is not a static object. It is a living structure, shaped by billions of years of cosmic history. It has grown from small beginnings. It has been wounded, healed, reshaped, and fed by its neighbors. Its beauty today is the result of countless past collisions, quiet inflows of gas, and the rhythmic rotation of its disk. It is a galaxy built by time, and you sitting here, on a small planet orbiting an unremarkable star, are part of this history. Every atom in your body was once part of the gas clouds, stars, or smaller galaxies that helped form the Milky Way. You are, in a very real sense, a byproduct of the galaxy's long, complicated past. The carbon in your cells was forged in ancient stars long before the sun existed. The oxygen you breathe was created in supernova explosions. The iron in your blood was cooked in the heart of massive stars that died billions of years ago, possibly in galaxies that no longer exist, swallowed by the Milky Way before the Earth formed. This is the quiet truth revealed by the history of our galaxy. You are not separate from the cosmos. You are its expression. The Milky Way's story is your story, written across billions of years, carried in the atoms that make you who you are. When we look at Andromeda in the night sky, a faint, gentle smudge barely visible to the naked eye, it doesn't feel threatening. It doesn't radiate danger or urgency. If anything, its soft glow seems calm, distant, almost shy. But that quiet presence hides a truth written in the slow arithmetic of gravity. Andromeda is moving toward us, not in a violent rush, but in a silent, inevitable drift, shaped by billions of years of cosmic motion. And one day, far in the future, long after our era has passed, our galaxy and Andromeda will meet. This meeting will not be an accident. It is the natural consequence of the way galaxies move through the universe. The Milky Way and Andromeda are part of the same gravitational family, bound together by the invisible mass that fills the local group. Their motions, though slow, have been drawing them closer for billions of years. And in about 4 billion years, the two great spirals will finally collide. But collision can be a misleading word. It suggests chaos, destruction, the smashing of worlds into pieces. Yet the reality is gentler, more elegant, and far more fascinating. Even though both galaxies contain hundreds of billions of stars, the space between those stars is so vast that when the galaxies merge, almost none of the stars will actually collide. Planets won't be pulverized. Suns won't slam into each other. Instead, the galaxies will pass through one another like ghosts, their stars weaving through the combined gravitational field in a slow, majestic reshaping of space. The real drama will unfold not from direct impact, but from the invisible pull of gravity. As the galaxies approach, their shapes will distort. Spiral arms will stretch and twist like cosmic taffy. Long tidal tails of stars will be drawn outward, forming faint ribbons of light that curve across millions of light years. Clouds of gas will collide and compress, triggering bursts of new star formation, brilliant waves of blue-white stars igniting in the darkness. Seen from a safe distance, the merging galaxies would resemble a ballet. Slow, graceful, almost impossibly beautiful. Two spirals approaching, interweaving, separating, then falling back together again, their forms shifting with each pass. The motions choreographed by gravity with perfect, patient precision. For roughly 1 billion years, the Milky Way and Andromeda will dance around each other. They will merge and separate, drawn together again and again until their individual shapes dissolve into one. The elegant spiral arms of both galaxies will be erased, replaced by a vast, swollen cloud of stars. The orderly rotation of each disk will dissolve into complex, intersecting orbits, and the two galaxies will become one, a massive elliptical galaxy that astronomers have already named Milky Way. Milky Way will be enormous, far larger than either galaxy is today. It will glow with the combined brilliance of two great spirals, surrounded by thousands of star clusters and wrapped in a halo of stars pulled from the galaxy's outer regions. Over time, the gas within Milky Way will settle, star formation will slow, and the new galaxy will grow quieter, more dignified, more ancient. Its appearance will resemble the giant elliptical galaxies we see in distant clusters today, vast, smooth spheres of stars glowing faintly at the edge of the universe. But what about the Sun? What happens to us? By the time this collision takes place, the Sun will already be nearing the end of its life. It will be hotter and brighter than it is today, its radiation slowly altering the Earth beyond habitability. Humanity, if it still exists, will have long since evolved, migrated, or found new worlds. Still, in the midst of the galactic collision, the Sun itself will survive. Like most stars, it will not strike another star. Instead, it will be flung into a new orbit, perhaps pulled outward into the halo, perhaps thrown into a long looping path around the newly formed Milky Way. Earth, if it remains intact, will experience a night sky transformed beyond imagination. Instead of the familiar band of the Milky Way, the entire sky will sparkle with the distorted arms of Andromeda sweeping across the horizon. Great arcs of light will stretch overhead like cosmic brushstrokes, shifting slowly over millions of years as the galaxies pass through one another. For anyone watching, it would be one of the most beautiful sights the universe can offer, a celestial mosaic drawn by gravity itself. And yet, despite the scale of this transformation, the collision is not a catastrophe. It is a natural part of galactic evolution. Spirals merge to form ellipticals. Small galaxies feed the growth of larger ones, and the universe, over billions of years, continues its quiet work of shaping and reshaping the structures within it. The merger of the Milky Way and Andromeda is not the end of our story. It is simply the next chapter. Milky Way will continue drifting through the local group, eventually merging with the Triangulum galaxy and other nearby systems. Over tens of billions of years, the galaxies of the local group will combine into a single massive structure, a lone island of stars in an increasingly empty universe. As cosmic expansion accelerates, distant galaxies will slip beyond the horizon, leaving Milky Way isolated, floating through a darkness where no other galaxies remain visible. In that future, the descendants of humanity, or whatever forms life takes, may look at the night sky and believe the universe is small, static, unchanging. They will see only the galaxy they inhabit, unaware that beyond the darkness, the universe once held trillions of galaxies now forever out of reach. They will know nothing of Andromeda, nothing of the local group, nothing of the cosmic web. Unless we leave them a record, this possibility gives our era a quiet significance. We live at a time when the universe is still visible, when galaxies still shine across the vastness, when the cosmic web can still be mapped, when the story of the universe can still be understood, and that understanding fragile, precious, and temporary rests with us. The future collision with Andromeda is a reminder that galaxies are not eternal structures frozen in time. They move, they grow, they merge, they transform, and we, in our brief moment of awareness, have a chance to witness this evolution, to understand how everything came to be, and to pass that understanding forward. The Milky Way and Andromeda are not racing toward destruction. They are drifting toward transformation, toward union, toward the next stage of their existence, and in that slow cosmic embrace, written across billions of years, we find a quiet truth about the universe. Nothing remains the same, yet everything continues. Galaxies merge, stars drift, light travels, and consciousness, however, briefly witnesses it all. As we look toward the far future beyond the merger with Andromeda, beyond the formation of Milky Way, beyond anything humanity will likely witness firsthand, a quiet shift in the universe becomes impossible to ignore. It is not dramatic. It is not explosive. It does not happen in a single moment. Instead, it unfolds slowly, steadily, without pause, like the soft stretching of a fabric pulled from its edges. This is cosmic expansion, the quiet force that has been shaping the universe since the first instant after the Big Bang, and over billions upon billions of years, it will reshape everything we know, not through violence, but through distance, not through destruction, but through separation. In the early universe, galaxies were much closer together. Clusters were more tightly knit. Light could travel across the cosmos and still arrive within a galaxy's lifetime. But as the universe expanded, space itself began to stretch, carrying galaxies away from one another. At first, this expansion slowed. Gravity resisted it. Structures formed. Galaxies clustered. Stars ignited. But then something unexpected happened. Around 5 billion years ago, the universe's expansion began to accelerate, driven by a mysterious force we now call dark energy. This acceleration continues to this day, and in the far future, it will reshape the cosmos into a very different place. Today, we can observe galaxies across the entire observable universe, 2 trillion of them shimmering like distant lanterns. Their light reaches us from billions of light years away. We can map the cosmic web, watch galaxy clusters form and merge, and study structures so large they defy imagination. But billions of years from now, this cosmic visibility will fade. Slowly, silently, galaxies outside our local group will accelerate away from us, faster than light can reach across the growing distance. Not because they are moving faster than light through space, but because space itself is expanding, stretching the distance between galaxies like dots on a balloon being inflated. One by one, the galaxies we see today will slip beyond the cosmic horizon, the invisible boundary beyond which no information can reach us. Their light, no matter how bright, will never arrive. Their presence will disappear not through destruction, but through isolation. Eventually, the only galaxies remaining visible will be those gravitationally bound to Milky Way, the merged remnant of the Milky Way and Andromeda. All others, even those relatively close today, will fade into darkness, receding faster than any message they send can bridge the widening gulf. The Virgo cluster will vanish from view. The great walls will disappear. The cosmic web itself, all its filaments, clusters, and distant structures will be erased from the perspective of any civilization living in that distant future. The universe will not become empty, but it will become isolated. Imagine standing beneath a future night sky. You look up not at a tapestry of 2 trillion galaxies, but at a single glowing structure, Milky Way, surrounded by perhaps a few faint dwarf companions. The universe will seem small, quiet, static, almost lonely. Future astronomers, if they exist, will have no way of knowing the truth we see today. They will see one galaxy, one island of stars, a single cosmic oasis floating in darkness, and without evidence of cosmic expansion, without light from receding galaxies. They might conclude that the universe is eternal and unchanging. This is the irony of cosmic knowledge. The more the universe expands, the less of it any observer will be able to see. We live at a privileged moment, one of the few epochs in cosmic history where the universe is still visible on a grand scale. Too early, and galaxies had not yet formed. Too late, and galaxies beyond our neighbors will be gone from view. But now, in this brief window, the cosmic web is illuminated in all directions. The universe reveals its vastness, its structure, its origin, and its fate. The coming isolation is not a catastrophe. It is simply the natural continuation of expansion. But its emotional weight is undeniable. The universe we know, rich, interconnected, glittering with distant galaxies, will fade into something quieter, more introspective, like a vibrant city gradually transformed into a solitary village, and this expanding darkness will have consequences beyond what we can easily imagine. As galaxies grow farther apart, fewer interactions and mergers will occur. The cosmic cycle of star formation will slow, gas will become scarce, star birth will dwindle over trillions of years. The night sky will dim as stars burn out and are not replaced. Yet even in this distant future, remnants of cosmic history will persist. The stars of Milky Way will continue their slow orbits. Ancient stellar corpses, white dwarfs, neutron stars, and black holes will drift through the darkness, silent witnesses to a universe long past its age of brilliance. And even as the void between galaxies grows, gravity will continue to bind together what remains, keeping pockets of light alive in an ever-expanding sea. It's natural to feel a kind of melancholy when imagining this future isolation. But inside this melancholy is a deeper truth, one that speaks to the fragility and beauty of knowledge. We are alive at the perfect moment to understand the universe. We can see galaxies that will one day be invisible. We can measure expansion that future beings will never detect. We can map structures whose light will soon slip beyond reach forever. In a strange and poignant way, the universe is telling us to pay attention now, to look, to learn, to understand. While the grand cosmic tapestry is still visible, and perhaps that is where the meaning lies, not in the permanence of the universe, but in our ability to witness its impermanence, not in the stability of galaxies, but in the fleeting chance to understand them, not in escaping isolation, but in recognizing the wonder of living in a cosmos that is, for this brief era, still open, still bright, still speaking. As the universe grows, it is not dying. It is transforming, stretching into silence, making space where once there was connection. And the story of that transformation, the quiet drift into cosmic solitude, is one of the most profound chapters in the history of everything. The universe is becoming larger, but what remains within reach becomes smaller. And in that shrinking circle of light, we find one last, lingering message. Cherish this moment in cosmic time. Cherish the visible universe while it is visible. Cherish awareness while awareness exists. As we trace the history of the universe from the birth of galaxies to the vast voids, from the cosmic web to the accelerating expansion that will one day isolate every island of stars, a quiet realization begins to emerge. It rises not from the equations or the measurements, but from the spaces between them. It is a realization that speaks not to physics, but to meaning, not to structure, but to significance. And it is this: life is rare. Life is fragile. Life is precious. The universe, for all its beauty, is not a gentle place. It is overwhelmingly empty, overwhelmingly cold, overwhelmingly vast. The conditions required for life, at least the kind we know, are astonishingly specific. Liquid water, stable temperatures, the right mix of elements, a planet small enough to hold an atmosphere but large enough to keep its heat, a star steady enough to shine for billions of years, a galaxy calm enough to avoid constant sterilization by supernovae, a cosmic neighborhood quiet enough to let evolution unfold slowly, without interruption, out of 2 trillion galaxies, each containing hundreds of billions of stars. Only a fraction will host planets with such balance, and of those planets, only a fraction will stay stable long enough for life to arise, and of those worlds, only a fraction will see life grow in complexity, learning, awareness, and of those rare cases, only a tiny sliver, an almost invisible thread, will ever develop consciousness capable of looking back at the universe and asking what it means. You are living in that sliver, on a world that should not, by probability, exist, in a galaxy shaped by impossibly ancient events, inside a universe that has spent billions of years arranging the conditions required for life to take even a single breath. When you understand the cosmos fully, when you see the size of the voids, the fragility of galaxies, the impermanence of stars, the expansion that will one day erase the visible universe, something inside you shifts. The universe is no longer just a backdrop. It becomes a mirror. It shows you what life is by showing you how rare it is. It shows you what consciousness means by showing you how fleeting awareness is on the timeline of cosmic history. It is tempting to think of the universe as indifferent. After all, it does not bend itself to our needs. It does not guard us from danger. It does not shape its evolution to protect life. Yet the existence of life here now is not a contradiction to that indifference. It is a triumph within it. Life is not the universe's purpose. Life is the universe's possibility, a rare, delicate possibility that emerges only when conditions align with extraordinary precision. Consider everything that had to happen for you to exist. A star had to form in a calm region of the Milky Way. A planet had to grow from dust, stable enough to hold oceans for billions of years. The Earth had to avoid catastrophic impacts long enough for life to evolve. Evolution had to flow down the exact pathways that allowed brains to form, language to emerge, curiosity to ignite. Then one day, consciousness looked up and noticed the stars. The universe has been unfolding for over 13 billion years, yet only now has something within it learned to reflect on itself. Life, in this sense, is not just rare. It is the universe becoming self-aware through the only tool capable of such a feat, the mind of a living being. And when you realize how rare life is, how improbable consciousness is, how brief this window of cosmic visibility truly is, something profound happens. You begin to understand that meaning is not something we wait for the universe to give. Meaning is something life creates in defiance of cosmic silence. The universe provides the canvas. Life provides the story. If life is rare, then kindness matters more. If consciousness is fleeting, then awareness becomes sacred. If the universe is vast and indifferent, then the connections we create are our rebellion against the void. In a cosmos where isolation is the default state, every act of understanding becomes an act of creation. Every moment of awareness becomes a moment of light. Every breath becomes a quiet celebration of everything that had to go right for that breath to exist. And this rarity is not a reason for despair. It is a reason for awe, because the more you understand the universe, the more miraculous life becomes. The more you learn about galaxies, the more precious Earth appears. The more you contemplate cosmic time, the more meaningful this moment feels, this single moment in which you are alive, aware, listening, thinking. It is easy, when facing the scale of the cosmos, to feel small. But smallness does not mean insignificance. If anything, your rarity increases your value. Diamonds are precious not because they are large, but because they are rare. Life is rarer than diamonds. Consciousness is rarer still, and your ability to reflect on the universe, to feel wonder, to search for meaning, to contemplate existence is one of the rarest phenomena the cosmos has ever produced. Think of all the galaxies drifting silently in the dark. Trillions of them. Most will never host life. Most will never produce anything capable of asking a question, feeling love, creating art, or telling a story. Yet here you are, a being made of stardust, capable of understanding the stars. Life may not last forever. Stars will fade. Galaxies will drift apart. The universe will grow colder and darker with time. But meaning does not depend on permanence. Meaning depends on presence. And for this brief, shining window in cosmic history, life is present. Awareness is present. You are present, and that presence matters. In a universe where nothing had to exist at all, existence becomes extraordinary. In a universe where life is rare, life becomes sacred. In a universe where consciousness is fleeting, consciousness becomes a miracle. The cosmos does not need to assign us purpose for us to have one. We give the universe meaning simply by being able to reflect upon it. And that, more than any galaxy, more than any great wall, more than any cosmic structure, is what makes life precious. When you contemplate the sheer scale of the universe, trillions of galaxies, vast voids stretching hundreds of millions of light years, walls of galaxies spanning billions, it becomes almost impossible to believe that the human mind, small and fragile, could ever hope to understand any of it. And yet, here we are, a species barely 200,000 years old, living on a tiny blue world orbiting an ordinary star, already mapping the cosmic web, decoding the history of space-time, listening to the faint radiation left over from the birth of everything. The ability of human beings to comprehend the universe is one of the greatest miracles of existence. It is not just unlikely, it is astonishing. For most of cosmic history, the universe evolved without witnesses. Stars burned in silence. Galaxies collided unnoticed. Light traveled for billions of years without anyone to see it. Then, in a small corner of a random spiral galaxy, life emerged, grew curious, and eventually opened its eyes long enough to discover the story written in the sky. Human consciousness is the universe learning to understand itself. Think about this. The atoms in your brain were forged in ancient stars long before the Earth existed. Those atoms drifted through interstellar space, joined collapsing clouds, formed planets, became oceans, became cells, became neurons, And those neurons now generate thoughts capable of reaching beyond the Milky Way, beyond Laniakea, beyond the observable horizon itself. You are made of stardust, but you are stardust that can think. The universe built the tools for its own comprehension. This ability did not appear suddenly. It grew slowly, through curiosity, mistakes, imagination, and persistence. Humans learned to look up at the night sky and ask questions. At first, those questions were simple. What are the stars? Why do they move? Where does the sun go at night? What lies beyond the horizon? But over time, those questions deepened. Curiosity sharpened. Patterns were noticed. Predictions were made. Then came mathematics, humanity's greatest bridge between thought and reality. With it, we learned to describe the movements of planets, the shape of galaxies, and the laws that govern everything from falling apples to orbiting moons. Then came telescopes, and suddenly the sky expanded. What seemed like a dome of stars became a vast universe. Nebulae turned out to be galaxies. The Milky Way transformed from everything to just one among trillions. The universe grew larger with every discovery, yet so did our understanding. This is one of the quiet triumphs of the human mind. No matter how large the universe becomes, the mind expands with it. Even when nature reveals something overwhelming, black holes bending space-time, quantum particles behaving unpredictably, galaxies racing apart as the universe accelerates, we find ways to understand it. Not perfectly, not completely, but enough to glimpse the laws beneath the mystery, and every glimpse expands our sense of meaning. Why can the human mind understand the universe? Why should creatures evolved for survival on a small planet be capable of grasping the age of galaxies, the life cycle of stars, the curvature of space-time? There is no simple answer. Some argue that intelligence is simply adaptive, a tool for survival that happens to generalize beyond earthly needs. Others believe that consciousness is a natural outcome of complexity, and some see something more poetic, that the universe produces life not just to survive, but to perceive, to witness, to reflect. But regardless of the explanation, the outcome remains extraordinary. The universe is vast, ancient, and complex yet understandable. And not just to scientists on mountaintops or in observatories. Anyone can look at the stars and feel the mind reaching outward. Anyone can learn the story of galaxies and feel wonder unfurling inside them. The ability to understand the universe is not limited by background or profession. It is a human inheritance, a gift of consciousness itself. Yet this gift comes with a responsibility. The universe will not always be visible as it is now. Galaxies are slipping away beyond the cosmic horizon. The sky will one day grow emptier. Future beings may not be able to see what we see today. We are living in the golden age of cosmic knowledge. We can study galaxies that will one day disappear into darkness. We can measure the expansion of the universe while it is still measurable. We can glimpse the earliest light of creation before it stretches beyond detectability. We are alive at the perfect time, not too early, not too late. And that timing gives our curiosity a purpose. To observe while observation is possible, to understand while understanding is accessible, to preserve knowledge that may one day be lost to the silence of expansion, because the universe is not waiting for us. It is changing, growing, stretching, becoming more isolated with time, and the window in which the cosmos reveals itself is brief, not in human years, but in cosmic epochs. We stand in that window. Humanity's ability to understand the universe is not just a scientific achievement, it is a philosophical revelation. It says something profound about our place in the cosmos. We are small, but not insignificant. We are temporary, but not meaningless. We are fragile, but capable of infinite thought. Out of all the particles drifting through space, out of all the stars burning in silence, out of all the galaxies spinning in darkness, you are part of the fraction of matter in the universe that can think, imagine, question, and understand. That makes your awareness rare, your curiosity valuable, your capacity for wonder precious. When you learn about the universe, you are not just gathering facts. You are participating in the greatest act of consciousness the cosmos has ever produced, the act of a mind, your mind reaching beyond itself to touch reality at its largest scale. And in that reach lies something deeply human, the desire to know where we come from, the courage to face our smallness, and the wisdom to find meaning not outside ourselves, but within our ability to understand. You are a moment of clarity in a universe mostly made of silence, a spark of awareness in a cosmos that spends most of its time unaware, a brief flowering of thought in a history dominated by stars and dust. And that is why the ability to understand the universe matters, because it transforms existence from something we inhabit into something we know. After traveling across cosmic structures, through trillions of galaxies, past vast voids, ancient collisions, distant futures, and philosophical reflections, we return at last to the Milky Way, our home. But we no longer see it the way we did at the beginning. What once felt enormous now seems delicate. What once felt central now feels quietly humble. And yet, in this humility lies one of the greatest paradoxes of the universe, a paradox that reveals something profound about existence itself. The Milky Way is both ordinary and extraordinary, both typical and utterly irreplaceable, both insignificant in the cosmic landscape and deeply meaningful to everything that has ever lived on Earth. This paradox sits at the heart of our understanding of the universe. On one hand, the Milky Way is just one spiral among 2 trillion galaxies. It is not the largest, nor the brightest, nor the most unusual. Its structure, while beautiful, is not rare. Its size is respectable but unremarkable. In the cosmic census, the Milky Way is middle class, a product of common processes replicated across the universe billions of times. From a purely structural perspective, there is nothing about it that demands special attention. And yet, here you are, living in it, thinking within it, understanding it. The Milky Way might not be special to the universe, but it is profoundly special to you, because it is the only galaxy in which your awareness has ever existed. It is the cradle of every story, every memory, every civilization, every triumph and mistake our species has ever known. It is the only place we have ever called home. Its stars shaped the atoms in your body. Its position in the cosmic web allowed your planet to form. Its calm spiral arms gave life the time it needed to grow, evolve, and learn. The paradox deepens when you consider that the Milky Way, in its ordinariness, produced something extraordinary. Life capable of understanding the universe, consciousness capable of reflecting on its own origins, minds capable of tracing cosmic history back to the dawn of time. Out of trillions of galaxies, only this one holds the story of you. And that is the quiet brilliance hidden inside the paradox. The universe does not need to make something rare in order for it to be meaningful. Meaning arises not from cosmic uniqueness, but from the simple fact of existence meeting awareness. As we explored earlier, the future will bring isolation. Galaxies will drift beyond the cosmic horizon. The night sky will grow emptier. The visible universe will shrink until only the descendants of the Milky Way remain within view. And when that happens, future beings, if any survive, may never know that 2 trillion galaxies once existed. They may never know about Laniakea, the cosmic web, or the Hercules Corona Borealis Great Wall. They may look up at the sky and believe the universe is small, but we know, and knowing is a gift. We exist at a moment when the universe is still open, still visible. We live in an era when the night sky still carries messages from billions of years ago. We can see galaxies that future eyes will never witness. We can understand structures that will one day fade into the darkness of expansion. And that gives our era a quiet responsibility to appreciate the universe not only for its grandeur, but for its timing, to value our place in the Milky Way not because it is rare, but because our ability to understand it is rare. The paradox of the Milky Way is this: it is ordinary in structure, but extraordinary in meaning. It is typical in formation, but unique in what it has produced. It is one among trillions, but the only one that contains your story. Think of everything that had to happen for this galaxy to exist. Dark matter had to collapse into halos. Gas had to cool and form stars. Dwarf galaxies had to merge and be consumed. Spiral arms had to stabilize. The sun had to form in a safe location. Earth had to remain calm for billions of years. Life had to emerge, endure, and evolve into awareness. This chain of events is not impossible, but it is delicate. It is precise. It is astonishing. And when you look at the Milky Way through that lens, it becomes more than a galaxy. It becomes a symbol of everything that has gone right against overwhelming odds to allow this moment of reflection to exist. We often search for meaning by asking whether the universe cares about us, or whether life has a designated purpose. But perhaps that question misses something deeper. Perhaps meaning does not come from the universe assigning us significance. Perhaps meaning arises when consciousness recognizes its own improbability and cherishes it. The Milky Way is not meaningful because it is rare. It is meaningful because you are here to witness it. Meaning is not inherent in galaxies. Meaning is created by minds, and so, in the end, this entire journey from cosmic scales to philosophical insights leads back to a single realization. The universe does not need to revolve around you for your life to be meaningful. It simply needs you to be aware of it. Your existence is the closing of a cosmic loop. The universe produced you, and now you have learned to understand the universe. The Milky Way is ordinary. You are not. Because you are the part of the galaxy that has learned to wonder and wonder. More than anything else, is the meaning that emerges from the paradox, the quiet truth that in a vast, indifferent cosmos, consciousness transforms existence into experience, and experience into significance.